Okay, so we'll move on with exercise 2F. This is exercise 2F, question number 6. We'll do one more question to work out the standard deviation. So they say here in a student group, a record was kept of the number of days of absence. Each student had over one particular term. The results are shown in the table. Number of days absent, you have 0, 1, 2, 3, 4, and then the frequency. So 12 students were absent 0 days. 20 students were absent 1 day. 10 students were absent 2 days. You can see how it goes on. So how do you find the standard deviation? Now for standard deviation, normally there are two equations we can go with. One, the equation that you work only with x, right? So this equation is sigma x square over n minus sigma x over n, the full thing square, the root of that. So this is only when you have a data set that does not have repeats, which in the sense you do not have frequency. So if there's no frequency, we go with this. So for a linear data set like this, where you have the x values all spread out like this, you can use that. But when there's a frequency, we go with this formula. So you can see sigma fx square over sigma f minus sigma fx over sigma f whole thing square. So we go with that if there's a frequency. So in our question over here, you can see we have a frequency. So we'll have to work with that. So we'll make a table. Okay, you can make a table or you can do it manual. So I'll go with the table. I'll make the x table. X is the number of days absent, frequency, and then we'll make a fx column and a fx square column. Okay, so let's do that. Okay, so you can see I have built the table with the values here. So x is the number of days absent, frequency is x. Okay. So inputting the value, x values are given to us as 0, 1, 2, 3, 4. Frequency values are given 12, 20, 10, 7, and 5. Okay, so now let's go for fx. Fx means you multiply the x value with the frequency value. 0 times 12 is 0. 1 times 20 is 20. 2 times 10 is 20. 3 times 7, 21. 4 times 5, 20. That's fx column. Then next you should get the fx square column. How do you get fx square? You multiply the frequency with the square of the x value. So it's 12 multiplied by 0 square. Isn't it? 12 multiplied by 0 square is simply 0 because it's multiplying with the 0. The next one, 20 you multiply with the square of 1. 20 into 1 square, which is 20. The next one, 10 into 2 square. So that is 10 into 4, that is 40. Next one, 7 into 3 square. So 7 into 3 square, 7 into 9, that is 63. Next one, 5 into 4 square. So 5 into 16, which is 80. Okay, so we got that. Now we have to get the sigma value of it, which means you have to get the addition, the total value. So let's get the total value of fx and fx square. So total fx, when you add everything, 0 plus 20 plus 20 plus 21 plus 20, how much is it? 81. And also sigma fx square, you add 0 plus 20 plus 40 plus 63 plus 80, how much is it? 203. It's 203. Okay. All right, so those are the answers. And then let's now apply the standard deviation equation. So standard deviation that's going to be, write the equation always. Okay, so write the equation, it makes you practice it better also. So sigma fx square is 203. Sigma f is, how much is the total frequency, by the way? I didn't add that. Total frequency is 54. Okay, so over 54 minus sigma fx is 81. Over sigma f is 54. Whole thing square and then you square root. How much is the answer? So it's a matter of typing the whole thing in the cal, right? Yeah, what do you get? 1.22851, it goes on, which means correct to 3SF 1.23, correct to 3 significant figures. Okay. Okay, so I'll move on to question number 7 in the same exercise, exercise 2F. Okay, so they say here a certain type of machine contained a part that tended to wear out after different amounts of time. The time it took for 50 of the parts to wear out was recorded. And they're asking you, okay, the results are shown in the table. Okay, so, okay. Okay, so then the table is given to you. They are saying here the manufacturer makes the following claim. 90% of the parts tested lasted longer than one standard deviation below the mean. Now, you know, here you're finding the standard deviation. They're talking something about the standard deviation and they're talking something about the mean. Okay, so before we actually go to test whether this claim is true or not, the first thing you should do here is to actually find the standard deviation and the mean. So let's construct a quick table and find the standard deviation and the mean, and then let's test the validity of this claim. Okay, so the lifetime H between 5 to 10, H between 10 to 15, H between 15 to 20, 20 to 25, and H between 25 to 30. Okay, the frequency 5, 14, 23, 6 and 2. Okay, so the next thing is to get the mid value. How do you get the mid value? You add the two values, the here 5 plus 10 and you divide by 2. So 5 plus 10 is 15. 15 divided by 2, 7.5. 10 plus, so to get the midpoint, add the two limits, divide by 2. 10 plus 15, 25, divide by 2. 12.5. 15 plus 20, that's 35, divide by 2. How much is it? 17.5. Next one, 20 plus 25 divided by 2. How much is it? How much? 22.5. Next one, 25 plus 30 divide by 2. How much? 27.5. All right, so we have our frequencies and our mid values. Now multiply the frequency and the x values. So multiply f and x. So 5 times 7.5, 30. 37.5. 14 times 12.5, 175. 23 times 17.5, 402.5. 6 times 22.5, 135. 2 times 27.5. Okay, and then fx square. How does fx square work? Fx square is you multiply the frequency with the square of the x value. So 5 multiplied by 7.5 square. 5 times 7.5 square. How much is it? 281.25. Next one. 14 multiplied by 12.5 square. 14 multiplied by 12.5 square, 2187.5. Next one, 23, you multiply by 17.5 square. So that answer is 7043.75. Next one, 6, you multiply with 22.5 square. So that is 3037.5. Next one, 2 you multiply with 27.5 square, which is 1512.5. Okay, right. So now to finish this off, we need the total. We need the total of the frequency column, and we need the total of the fx column and the fx square column. So I need the total of all those columns. Frequency column, what's the total? 50. Fx column, what's the total? 860. 5. Fx square column. What's the total? 14,062.5. Guys, do you agree with this answer? All you have to do is to add everything over here. Okay, simply add everything over here. Okay, so now time to apply it into our equation. First, let's find the mean and the standard deviation. Okay, so what's the mean? Mean equals to sigma fx over sigma f. Sigma fx is 805 over sigma f is 50. Answer is 16.1. Okay, and then let's go for the standard deviation sigma. Sigma is sigma fx square over sigma f minus sigma fx over sigma f whole thing square and then square root. So let's input the values. This is the standard deviation. Sigma fx square is 14,062.5 over sigma f is 50 minus sigma fx is 805 over sigma f is 50 whole thing square and then the root of it. Okay, so everything you can give the whole thing together in the cal in one go. It gives you the answer 4.694677838. It goes on. So you can make it, we'll write a few extra decimals. 4.694677838. It goes on. It goes on. Okay. Right. So then you can round it off. 4.69, right? To 3SF. Now remember, what are we finding the standard deviation and mean of? We are finding the standard deviation and the mean for what here actually? We are finding the standard deviation and mean for the lifetime. The lifetime in hours for what? The lifetime in hours for a certain type of machine, right? Now, a certain type of machine contain the part that tended to wear out after different amounts of time. So basically, we are testing the lifetime of this particular part. Okay, so the average lifetime of the part is 16.1 hours because lifetime was measured in hours. And the standard deviation means how much it varies from the mean. Like how much it can vary from the mean. So from the mean, the lifetime tended to vary in between 4.69 hours. So some parts were 4.69 hours below the average, some would go more than. So most of the parts would be within that range. Okay. All right. Now the claim, let's actually go for the claim now. So what are they saying here? The manufacturer makes the following claim. 90% of the parts. Okay, now you know we have how many parts here? We have 50 parts, right? Now he says 90% of the parts lasted longer than one standard deviation below the mean. Okay, so one standard deviation below the mean. Okay, so what do you mean by one standard deviation below the mean? How do you get one standard deviation below the mean? You subtract what whom from whom? One standard deviation below the mean, right? So which means one standard deviation means this is one sigma. Below the mean. Mean means the x bar, the mu. We give it by the term mu. Okay, mean. Okay, the x bar, you can say, you use these letters. Okay. So one standard deviation below mean means what from? Obviously below, the word below means you are going to perform a addition, subtraction, or what? Multiplication. What do you do if it's below? Below means it has to be a subtraction. Okay, whom are you subtracting? One standard deviation below the mean. So below the mean, isn't it? So then are you going to do mu minus 1 sigma or sigma minus mu? Obviously it has to be mu minus, right? Because you are going one standard deviation below the mean. So from the mean, you have to subtract 1 sigma. If they said 2 standard deviation below the mean, you would do mu minus 2 sigma. Okay, so let's get the value. What's the mean value? Mean value was 16.1. Mean value is 16.1 minus what was the sigma value? 4.69. Let's get it to this. 4.69. So how much is it? How much is it? 11.41. Okay, so 11.41. All right, so I'm going with 2 decimals for the standard deviation. You can make it 3 decimal and they want, okay, so we just have to get the percentage. Okay, so actually decide on a fixed percentage and then go with it. Okay, so I'm going with 2 dps for the, I'm going with 2 dps for the standard deviation. So I'm getting the value here 11.41. Now you need to realize what is this 11.41? It's 11.41 hours, right? Because your mean comes in, the mean is the lifetime. That's 16.1 hours. Standard deviation is also in hours. So then mean minus 1 sigma 11.41 hours. Now what is the manufacturer saying? He's saying 90% of the parts tested lasted longer than 11.41 hours. That is the claim. Okay, you can rewrite the claim. What is the claim? What the manufacturer says is, he says 90% of parts tested last longer than 11.41 hours. So your task is now what? Your task is to find out if this statement is true or false. You have to see whether this is correct or not. And you have to do the relevant calculation to check on this. So how do you do this? How do we check on this? Obviously, what do we do? So what do you have to do here? 90% of the parts, isn't it? So what you could do here is you can actually find the 90th percentile. Isn't it? 90th percentile means it covers 90% of the data. And you can see, check whether the 90th percentile covers 11.41 hours. Okay, with the 90th percentile, if it is below 11.41, then you can understand that the manufacturer, what he says is wrong, isn't it? Okay, so let's check whether this is whether this claim is correct. So first, let's find the 90th percentile. So how do you find the 90th percentile? So 90th percentile. 90th percentile. So we are going to find the 90th percentile. Okay. So how do you find the 90th percentile? P90. That's 90 over 100 into 50. So how much is it? 45. Okay. All right. So we get 45. So now that's the cumulative frequency. Okay. So I think you can see I have not built a table for the cumulative frequency. Shall we quickly do that? We need a column for cumulative frequency, right? Cumulative frequency. So at the cumulative frequencies, because when you're doing interval, you know, now this is what data we are dealing with. We are dealing with continuous data, which means to get the answer, you must apply linear interpolation, right? So you have to go interpolation, which means you need to have the cumulative frequencies in order to work with it. So 5, next one, 5 plus 14 is 19, 19 plus 23, 19 plus 23, 42, 42 plus 6, 48, 48 plus 2, that's a 50. All right, so then let's go to find the 90th percentile. So you draw the line 45. To which column does it fall? 45 doesn't fall. To check the cumulative frequency. So 5, no, 45 is more than 5. 19, 45 is more than 19. 45 is more than 42, so it doesn't have. 48 is the first person to pass 45. So 48. So this belongs to which group? 40 belongs 20 to 25. So 20 to 25, isn't it? 20 to 25. Okay, and then I think we don't even need the calculation, isn't it? Why? I think you can see the 90th percentile is actually falling between what? The 90th percentile falls between 20 and 25 hours. What's the manufacturer's claim? He says the 90th percentile is 11.41 hours. Now do you see that our 90th percentile is way above that? Do we actually even need to find it now? Because we can clearly see 90th percentile falls between 20 and 25 hours. Okay, so what does this tell us about the manufacturer's claim? The claim is false, isn't it? Okay. Let's write, let's give a statement on this. Okay, guys, over here, actually, the 90th percentile is not actually what we need to find. Let me explain it to you. Now, they are saying here the claim is that 90% of the parts are lasting Now he claims that 90% of his parts last longer than 11.41. Guys, when we find the 90th percentile, what are we actually doing? 90%. We find the place, we find basically the place where 90% of the parts fall into which category? Like behind 90%. Okay, so if I show you, if this is our data set, okay, if this is our data set, okay, so this is the 0%, so 90%. So 90th percentile means we are finding how many data parts are in this part. Is that what we are supposed to do? They are saying, you know, he is saying 90% of the parts what last lesser than, if he saying 90% of parts last lesser than 11.41. If we say that it lasts lesser than, then what we do here is correct, isn't it? Then we have to find the 90th percentile. But he says 90% of the parts last longer than. Now this is the lifetime. I have drawn here the axis. Let me redo this. So here, what we need to do here is, if this line here represents the lifetime. Okay, so over here 0%, and over here it represents all the complete total percentage. Okay, he says 90%. So there is a value here, this 11.41 hours, right? So he says that 90%, he says that 90% of the parts are lasting more than this. Can you see? So he says that his claim is that this percentage is 90%. Can you understand? So if this is the lifetime, he says that 90% of the parts are having a lifetime of more than this amount. Can you all understand? Which means below this 11.41, how much of a lifetime is there? Which means, in other words, only 10% of parts will last lesser than 11.41 hours. Okay. So in other words, only 10% of the parts will last lesser than 11.41 hours. So now we need to check whether this claim is correct. Are you with me? So we have to check whether this claim is correct. So one way of doing this would be not to find the 90th percentile, but to find the 10th percentile. So 10th percentile means you get this amount, this the 10% of your of the data set, and you can see whether the 10th percentile is 11.41 or not. Shall we check on that? So let's check the 10th percentile. Okay, I hope you guys are getting what I'm saying here. Okay, so let's check whether this claim is true. Okay, so I want to see if this percentage is 90%. Okay, that's what we want to do. Okay, so let's remove this. Let's go for the 10th percentile. What's P10? 10 over 100 into 50. How much is it? 5. Okay, so 10th percentile is 5, right? 10 over 100 into 50. Okay, so then how does it work? 5. Okay, so I think you can see the value with the cumulative frequency 5. How does it work, children? The cumulative frequency is 5, right? I think you can see cumulative frequency 5 is immediately there, right? Do we even need to perform interpolation? Can you see 5 is already there here? For 5, for cumulative frequency 5, what is the lifetime? For cumulative frequency 5, the lifetime is immediately 10, because you know for this 10, for the lifetime 10, it corresponds to cumulative frequency 5. For lifetime 15, it corresponds to cumulative frequency 19. Isn't it? If you have a value in between only, you have to perform linear interpolation. But if you are at the corner, you don't need to. Okay, because you can see here cumulative frequency 5 corresponds directly to a lifetime of how many hours? 10 hours. Okay, so which means the 10th percentile is actually what? The 10th percentile is actually 10 hours. But what does the manufacturer say? So we have the 10th percentile, P10. Are you guys with me? P10 is actually 10 hours. This is what we get from our data. Guys, are you with me? So what is the manufacturer's claim? What does the manufacturer claim? He says that the 10th percentile is 11.41 hours. Okay, so you can see the 10th percentile is actually what? Lesser than what he says, right? Which means now which means what do you have to say about the 90%? Which means you can say the truth is that 90% of the parts are lasting longer than how many hours? Only 10 hours. Is 90% of the parts lasting longer than 11.41 hours? So you see the correct 10th percentile is 10 hours. So if the 10th percentile is 10 hours, in other words, 90% of the parts will last longer than 10 hours. So you agree? So you can say here, which means what? 90% of parts last longer than 10 hours. But the manufacturer claims what? 90% of the parts are lasting longer than 11.41. Can you all understand? So then is his claim correct? No. So manufacturer's claim is false. Guys, this is really important that you need to understand, especially the word lasting longer, lasting lesser. Okay, because that needs to be clearly understood. When they say lasting longer, you need to immediately understand that this is the grade, the part that comes after. So 90% comes after this 11.41. Okay, so when we find percentiles, remember we are finding from the beginning. So that means if 90% of the parts last longer than 11.41 hours, in other words, it means 10% will last lesser than, and this lesser than part only we can take for the percentile. The lesser than part only we take for the percentile. So if I took the 10th percentile, I found the 10th percentile is immediately cumulative frequency 5. It corresponded directly to the lifetime of 10 hours. So if the 10th percentile is 10 hours, it means 10% of the parts last less than 10 hours. 10% of the parts last less than 10 hours. In other words, it means 90% of the parts last longer than 10 hours, which automatically what makes the manufacturer's claim false, because he is saying a value that is higher than the real value. Can you say so? Maybe to increase sales, to make this look good, he is saying a claim that is more than what is really there. Okay, can you understand? So manufacturer's claim is false.